We are on Unit 6, and in this unit, this is another pretty big, hefty unit for us. We begin with some more antiderivatives. Okay, we're going to begin by taking a look at antiderivatives. In this first section, we're going to cover what we call u-substitution. And in the next few sections, we'll look at integrals involving 1 over x and exponential functions. Okay, so in this section we're doing u-substitution. So first of all, let me just introduce this to you. Let's start with something that we already know how to do, and we'll try to morph that a little bit. So let's begin by taking a look. What if we had just x to the 5th in here? Well, we know that for this one we would just use the power rule for integration, and we would raise the power by 1 and then multiply by the coefficient divided by our new power. So that would be 1/6 plus c. This looks a little bit funny. That's 1/6 x to the 6th. The x is not in the denominator, right? Okay. So that's just power rule, right? The question is, what if it's not just an x? What if it's something more than an x? What if it's like 2x plus 3 all to the 5th? Well, up until now, we would have to actually multiply this out and then apply the power rule. So up until now, pretty much for polynomials, that's all we had. All we had was the power rule. So this is a great example of when we would use u-substitution. Okay, and here in general is how that works. Okay, what we do is we do a substitution. We come off to the side, and we let u equal something convenient. In this case, let u equal what's inside those parentheses. Okay, if we let u equal 2x plus 3, then this integral becomes u to the 5th dx, doesn't it? Well, that's the problem, because we have u to the 5th, but we have a dx. We need to change this dx to a du. So come back to your u equals 2x plus 3. We want to change dx to a du, so let's take the derivative of both sides with respect. We're taking the derivative of both sides, okay? If we take the derivative of both sides with respect to x, let me show you how this would work. If we take the derivative of both sides with respect to x, then we would have du dx, right, is equal to 2. And now watch this. I'm going to multiply that dx to the other side. This is called differential form. So du is equal to 2 dx. Okay? This is great because now I got just dx, or I have dx here. And to get dx by itself, I'm going to multiply both sides by a half. So 1/2 du is equal to dx. And now I see in place of dx, I can write 1/2 du. So that becomes u to the 5th times 1/2 du. Right? Which is 1/2 u to the 5th du. So u-substitution allows you to substitute u in place of an x expression. Okay? You always have to change dx to a du, but you don't just switch it to du, because oftentimes, not every time, but oftentimes it's not a straight dx equals du. Usually there's something else being multiplied by the du that you substitute in for the dx. Okay? And from here, we do what we've always done. We just use the power rule. Now this is really easy, right? So raise the power by 1, multiply by 1/6, right? So that would be 1/12 plus c, right? And lastly, we substitute back our x expression for the u. So u was 2x plus 3, so this will be 1/12 2x plus 3 to the 6th plus c. Let's take a look at what we found. I'm rewriting my problem, we found that the integral of this was equal to 1/12 2x plus 3 to the 6th plus c. We found that that's true, right? So let's take a look. Does that make sense? Does it make sense that this thing would now be to the 6th power? How did we get the 1/12? Well, the 1/12 was that 6 times a 2, right? Where did that 2 come from? Oh, it came from the derivative of this. Huh. So it was 1 over 2. So that 1/2 undid that derivative. Okay, let's go look at some more examples. Okay, so let's go back to our little notes page now that we've kind of introduced this to you. Okay? All right, this first example, let me see if I can't blow up this a little bit. Focus. There we go. Okay. It's still a little blurry. Okay. So in this problem, think about what we're doing. We just want the antiderivative, so we could multiply this whole thing out and apply the power rule, but it gets a little tedious with this 5th degree up here. If it was just a 2, I would probably just multiply it out and then use the power rule. But with the 5, let's use a u-substitution. So we're going to let u come off to the side, and we're going to let u be the x squared minus 1. Okay? So right now we have the integral of x u to the 5th dx. We need to get all u's in here, all right? So over here, let's take the derivative of both sides. We're taking the derivative of both sides with respect to x, right? Except I'm just going to go ahead and write it in differential form. So this would be du dx, right? This would be du dx, but I'm going to write that dx over here on this side. So du will equal 2x dx, right? Let's solve this for dx. So I need to divide both sides by 2x, right? So du divided by 2x would equal dx. So now I know I can replace dx here with du divided by 2x. What happens to the x's? The x's divide out, don't they? And so we have the integral of 1/2 u to the 5th du, because the x's cancel out there. Okay? Now power rule. So now for the power rule, u to the 6th times 1 over 12. That's 1/2 times 1/6 plus c. And then lastly, go back to x's. So this will be 1/12 x squared minus 1 to the 6th plus c. Okay? All right, next example, number 2. All right, so for this one, we really can't like square this or raise it to the 5th power or whatever. This 2/3 power, we have to use a u substitution on this one. So we'll come off to the side, all right? And u will equal 6x minus 1. So right now I have 4u to the 2/3 dx, right? So we're going to come over here, take the derivative of both sides. This would be du dx, but I'm just multiplying, the dx is going to come over here on this side. All right? So this is equal to 6 dx. Okay? So dx is equal to 1/6 du, or you could call that du over 6, either way. So let's come and substitute everything in. The 4 stays a 4. This will be u to the 2/3. And in place of dx, I'm putting 1/6 du. As soon as you have no x's left, you know you're good to go. Okay? This will be 2/3. If we wanted to, that 2/3 we could take completely out of the integral, couldn't we? Because you can do that with a constant. We could, if you want to, you can do that. We could have done that back here too. We could have taken this 1/2 outside of the integral. Okay, u to the 2/3 du, right? And now power rule. In the end, it's still always power rule, you guys, okay? So 2/3 times u to the, all right, this would be 2/3 plus 1, so 5/3. And then 1 over 5/3 is 3/5 plus c. And then lastly, we just go back to x's. I'm going to clean this up a little bit. 2/3 times 3/5 is 2/5. And then 6x minus 1 to the 5/3 plus c. And this is u-substitution. That's all it is. Okay? Number 3. Now we're starting to get really complicated looking. But ask yourself, I mean, we have to get down to power rule. We have to. So what's a way to get down to power rule? Well, let's let u equal, let's let u be what's inside of that cube root. So 2x squared minus 1. Think of what we're doing. We let u be what's inside the parentheses. We let u be what was inside the parentheses. We let u be what's inside these parentheses that is a parentheses to the 1/3 power, right? Lots of times that's what you do for u. Okay? All right. So now I know what u is. Let's take the derivative of both sides. So this would be du dx, but I'm going to again put the dx on the right side. Here we would have 4x, and then we're multiplying that by dx. Divide both sides by 4x. So now we're substituting in place of the x, we are putting du over 4x. And what will happen with those x's? They're going to cancel. Okay? So we will have, when I put this in, I'll have x on top, I'll have u to the 1/3, that's the cube root of u, right? And then here, in place of the dx, I have du over 4x. The x's cancel. So we have this 1/4. I'm going to take that 1/4 outside of the integral. I prefer to do that. And then we have u to the negative 1/3. Remember, the only thing we have is the power rule, so you have to write it as u to an exponent, not 1 over u to an exponent. It has to be u to an exponent here. Okay? Now power rule time. U to the negative 1/3 plus 1 is 2/3. 1 over 2/3 is 3/2 plus c. And now just clean it up a hair. 3/8. Replace u with your x expression. let me show this to you a slightly different way. Okay, right up here where we found du. We found du is equal to 4x dx. Do you guys see the x dx? This is x dx, isn't it? So I could leave that x with the dx and just say 1/4 du is equal to x dx, right? So in that case, in place of the x dx, I'm putting 1/4 du. And that's how I'll get that 1/4 out here. It's like you go straight to this step, but you just don't write those x's, right? So either way, they both mean the same thing. I have students who really like to solve it for dx and put that in and then cancel your x's. But you could leave the x over on the right hand side and just substitute in for that. Okay? Everything's logical. Okay? It is all mathematically correct. These are all valid substitutions. Okay? Another thing. We call it u-substitution. There's nothing magical about u. We could do a v, we could do a y, we could do any letter that we like, right? Except for x, because that has meaning in the problem. Okay? So just know you can do a different substitution if you want, but u's are pretty common. Okay? All right. Let's come over to this example. This one's a little bit harder because we have kind of two sets of parentheses here. These ones on top are not really necessary. I'm not sure why I put those there, but they're really not necessary. What would you, again, the only thing we have, you guys, is the power rule. So we've got to get down to the power rule. Each time we're getting down to the power rule. Okay? U to an exponent, u to an exponent, u to an exponent. We have to do that. So what should you let u be here? Well, let's let u be what's inside this thing being squared on the bottom. So in that case, u would be x squared plus 4x minus 3. And let's see what happens. Sometimes it takes more than one shot to see what the right u should be, you guys. So if you let u be something and it doesn't work out, meaning it doesn't cancel all the x's and stuff in the problem, then try something else. Okay? So here du is equal to 2x plus 4, and then remember, this would be du dx, but we're writing that dx on this side. Okay? Okay, well, let's take a look at this. Look at what we have. We have x plus 2 dx. We have that, right? So do you see an x plus 2 in here? I do if I factor out a 2. You agree? So we could right here divide both sides by 2 times x plus 2 and then put that in, and the x plus 2's would cancel. We could do that. Or we can leave this piece here because it's right there and move the 2 over and then we're substituting in place of this, we're substituting in 1/2 du. In place of the denominator, we just have u squared, right? So this becomes, excuse me, this 1/2. I'm going to take that 1/2 outside of my integral. And so now I just have the du there. Du divided by u squared. So that is u to the negative 2. Remember, you have to write it, you have to at least think of it as power, something you can use the power rule on. So if it's in the denominator, you've got to move it up. Okay? Now we can use the power rule. So we have 1/2 out front, and then u to the, add 1 to your exponent, right? and then divide by that. So 1 over -1, which is be -1, right? Plus c. So this is negative. This would be a -1/2 times 1 over u plus c, right? Let's go back to x's. So we have -1 over 2, and then u was, x squared plus 4x minus 3 plus c. This would be the, it'd probably be the multiple choice answer for this one. Okay? All right, u-substitution, not bad, right? Okay, let's do this one. All right. Well, certainly can't use the power rule here. So what would you let u equal? I'm going to let u be what's inside of that radical because that's the problematic thing that I'm seeing. Okay. So u is equal to just x minus 4. So what does du equal? Well, du dx would just be 1, right? So multiply by the dx. So in this case, du is equal to dx. So I can replace dx with du, right? So this will be just u to the 1/2 du. What do I do with this though? I have to change it to something with u's in it. What do I do? What happens here? Well, keep in mind, u is x minus 4, so what is x? X is u plus 4, right? So in place of this x, I can put u plus 4, and then it becomes u plus 6. U-substitution. So everything becomes u's. You should have no x's left. But you can't just make them disappear by snapping your fingers. You have to do something to make them just go away. Change them to a u expression. Now I can distribute. So now I have u to the, what is u times u to the 1/2? Well, you add your exponent, so that'll be u to the 3/2. And then we have 6u to the 1/2 du. And now, power rule time. So we went from something like this that we really had no idea what to do with, tried u-sub, and now all of a sudden we have power rule opportunity. So this will be u to the 5/2 when you add 1 times 2/5 plus u to the 3/2 times 2/3. So 6 times 2/3. Can we do that in our heads? 6 times 2/3. The 6 and the 3 would cancel to 2, and then 2 times 2 is 4, so this becomes a 4 plus c. Okay? Go back to x's. So we get this. And that is our safe stop spot. That is our safe stop spot when you go back to x's. And if it's a multiple choice test, maybe that is one of the choices. Look and see if it is. But I know sometimes they like to do something to this type of an answer. So let me show you what they sometimes like to do to get one of the multiple choice answers, okay? First of all, think of it this way. I see something in common. So let's factor it out. I see an x minus 4 in common, right? How many, I'm going to leave a space here. How many x minus 4s are in common? Well, you take the lowest of the exponents. So x minus 4 to the 3/2 is in common, okay? Now let's look at the numbers. At first glance, it looks like nothing is in common, right? between a 2/5 and a 4. Let me show you what they'll do though. They're going to take out a number so that there are no fractions left inside. So they will take out something over 5. They don't want any fractions left inside. Okay? Now, since we're taking out a something over 5, let's see what over 5 we could take out. If you only look at the numerators here, I see a 2 in common, so I can take out a 2/5. Okay? We'll do a couple of these. I know this is weird. All right, so that's what we're taking out. So the 2/5, when you take something out, you're dividing it out. So 2/5 divided by 2/5, we'll just leave a 1, right? And then x minus 4 to the 5/2 divided by x minus 4 to the 3/2, how many x minus 4s does that leave? It leaves x minus 4 to the 2/2, which is just 1. And x minus 4 to the 1 is just x minus 4. Okay? Go to the next term. The x minus 4 to the 3/2 divided by x minus 4 to the 3/2, that doesn't leave any x minus 4s left. What is 4 divided by 2/5? Come off to the side. We want 4 divided by 2/5. That's the same thing as 4 times 5 over 2, right? 10. So that leaves a plus 10. Remember that you can always multiply back and get that number to make sure you did it right. What is 2/5 of 10? That's 4. You can always multiply back and get this back. Okay? Plus C. So then possibly a multiple choice answer would look like this. Okay? Just a couple more steps. Kids in general hate this. They're like, oh my gosh, why would you do that? AP feels sometimes that this is simpler looking than that. I don't know if it is or not. It is a product rather than a sum. I don't know. Whatever. I'm just showing you what to do. Okay? Number 6. This will be similar. Alright? Alright. So, definitely a u-sub because it's not power rule and I can't do anything to make it power rule with x's. So let's do a u-sub and hopefully make it a power rule with u's instead. I'm going to let u be what's inside of my square root because that's where my problem area is. So u is x minus 6. du dx is just 1. So I'm going to take that dx over on the other side. This is, again, this is called differential form, you guys. Instead of derivative form, it's called differential form. Du is a differential of u, dx is a differential of x. Okay. So, another straight substitution. Dx is du. The only thing I need to change is this x minus 5 up on top then. So, x is equal to u plus 6, right? So if I put u plus 6 in for x, I'll have u plus 6 minus 5. So that will leave on top u plus 1, right? So on top now I have u plus 1. On the bottom I have the square root of u, which is u to the 1/2. And then remember dx was just du. Oops, dx was du. Okay? All right. Time to make this, it's still not power rule friendly, so let's, since there's a single u in the bottom, let's apply it, do what we do. We apply it to both terms on top, right? So this becomes the integral of u to the 1/2, because u divided by u to the 1/2 is u to the 1/2, plus 1 over u to the 1/2 is u to the negative 1/2, and now it's power rule ready. We're ready to go. So we'll have u to the 3/2 times 2/3 plus u to the 1/2 times 2 plus c. Go back to x's. U was x minus 6, so we're putting x minus 6 back in. Oops, 1/2. Okay? And that would be our safe stop spot, and maybe that is their multiple choice answer. I have seen them leave it in a multiple choice answer like that. But if they didn't, let's take out what's in common. So we are definitely taking out, I'm leaving a space for a fraction, but taking out an x minus 6 and how many? The biggest exponent, the 1/2. Okay? Now what fraction would they take out? Well, the only denominator is a 3, so they'll definitely take out something over 3. And if you look in the numerators, what can come out of the numerators? Well, a 2. Okay? What's left? Well, there's nothing left from the 2/3. 2/3 times what is 2/3? Just 1, right? Okay. What's left from the x minus 6's? X minus 6 to the 3/2 divided by x minus 6 to the 1/2 is x minus 6 to the 2/2, which is 1. So just x minus 6 to the first. Okay? For the second term, there will be no x minus 6's left, but we need to divide 2 by 2/3. So come off to the side. 2 divided by 2/3. That's the same thing as 2 times 3/2, right? Which is 3. So there's just a 3 left inside. And you guys, if you multiply 2/3 times 3, do you not get 2? Yes. It all makes sense. So then we would have 2/3 x minus 6 to the 1/2. They might write that as a square root. And then x minus 3 plus c. So that's possibly a multiple choice answer. Possibly. Or this might be their multiple choice answer. I would definitely check it out and see. Okay. All right, let's see. Let's do some trig functions. So this is not just a cosine of x. Since it's not just a cosine of x, it's cosine of a 4x, let's let u be 4x. So du would be, what's du? Du would be 4 dx. So 1/4 du is equal to dx. So I'm putting in place of the dx, I'm putting 1/4 du. The 1/4 I'm going to take outside, and then I will be left with cosine of u du. We know what the antiderivative of cosine of u is, and that is sine of u. So this will be 1/4 sine u plus c. Go back to x's. Okay, so let's see what we found out. We found that the integral of cosine of 4x dx is equal to 1/4 sine of 4x plus c. So what do you guys think the integral of cosine of 6x would be? Not too hard to figure out what that would be. Right? So we're taking the antiderivative of the function, keep your argument, right? And then just multiply by 1 over the derivative of that argument, right? Make sense? Okay. Over here, number 8. Okay, if it was just secant x tangent x, I know what the antiderivative of secant x tangent x is. That's just secant x. Well, I don't have just secant x. I don't have just an x here, sorry. I don't have just an x here, I have a 10x. So let's see if we can use what we learned over here. This will be secant of 10x, right? But we need to multiply by 1 over the derivative of our u, so 1/10 plus c. So this was doing u sub, you guys. We just didn't write it all out. If that bothered you, write it all out. Do what we did over here in number 7. Okay? All right, a couple more. What about this one? Do we know a trig function whose derivative is sine cubed x times cosine x? No, we don't. So we are going to need to do a u sub. Question is, what should we let u equal? Well, what is being raised to the biggest power? Sine x's, right? So I'm going to let u be sine x. What is du then? What's the derivative of u? Well, the derivative of sine is cosine, so that'd be cosine x. And remember, we're multiplying the dx on the side, right? And all of a sudden, look what's sitting there. Look what I see. We can substitute in place of cosine x dx, we can put du. And in place of sine x, we can put u. So this becomes the integral of u cubed du. It's like magic. Went from something very complicated looking to all of a sudden just a very simple little power rule. And then at the end, go back to your x's. So u is sine x, so I'm going to write this as sine to the 4th x plus c. Okay? What about this one? I can see a couple different ways to do this one, actually. But there's one way that's far easier. This is where kids say, Miss Murray, how do you know what to let u equal? Well, trial and error. And the more you do, the better you will get at seeing what needs to happen. Over here, you guys, we let u be sine x. The derivative of sine x was sitting right here, wasn't it? Yeah? So that was helpful because of the process. That's very helpful. Over here, secant squared is the derivative of tangent x. So if I let u be tangent x, then du will be secant squared x dx, and I can substitute in right there. This is my du, and this will be u squared. So all of a sudden we have u squared du. Very simple power rule now. 1/3 u cubed plus c. Go back to x's. 1/3 tangent cubed x plus c. Okay? All right. Now, let's take a look at integrals that have boundaries, so definite integrals. Okay. For definite integrals, and you can read this, for definite integrals involving u-substitution, it is sometimes convenient to determine the limits of integration in terms of the variable u. This is called changing the limits. Okay. And you can read that. You don't have to change the limits. You could keep your x limits if you write something. Okay. So remember, it's very important to communicate what we're doing effectively and correctly. So just keep that in mind, that we need to make sure that each line is equal to the line in front of it, okay? Okay, let's begin by doing our little u sub. We're going to go off to the side and we're going to say u is equal to 1 minus x squared, okay? Du is negative 2x dx. I see the x dx. I see the x dx. So if I move the negative 2 over, then I can substitute negative 1/2 du in place of that x dx, right? So that would be negative 1/2 integral, and then I would have the du in place of that, what's left from my x dx. So du in there, and then this will be u to the 1/2, right? So I put negative 1/2 du in place of the x dx, and then I put u to the 1/2 in place of the square root of 1 minus x squared. Okay? Now, I want to put equals, but I need to be careful. This was a definite integral, and right now I don't have it as a definite integral. I don't want to put 0 and 1. Why would I not put 0 and 1? Because those are x values. These are values of x, and I certainly don't want to put them here because then this would not be equal, okay? There are two ways around that. I'm going to show you the way that I prefer, okay? What I prefer is to change these to u's, and it's really easy because you have a little formula for u. The top boundary is a 1. So when x is 1, what is u? Well, it would be 0. So as a u boundary, that top boundary is 0. Put in the bottom boundary for x. The bottom boundary here is would be u is equal to 1 minus 0, which is 1. So our bottom boundary would be 1. Now this is equal. Okay? And so now we get to use just the power rule. So u to the 3/2 times 2/3 evaluated from 1 to 0. I probably should have fixed that before I did this, but I want to show you that this will work out just fine. In a definite integral, this works out just fine. If I'm not like going and looking at a graph to find areas, this is absolutely fine to do. Okay, it'll all work out just fine. So this is negative, I'm going to multiply this together. So that would be a negative 1/3. And then I put 0 in for u, minus, now put 1 in for u. So this becomes 1/3. If we had switched these boundaries and multiplied by a negative, that would be a 1/2 integral 0 to 1 of u to the 1/2 du, right? So this would be u to the 3/2, again, times 2/3, evaluated from 0 to 1. This would be 1/3. And then plug 1 in for u, minus plug 0 in for u, and we still get 1/3. I wanted you to see that they both work out the same. So in a definite integral that you are evaluating by hand, you can definitely leave them with the top less than the bottom, okay? If you're going and finding information from a graph, though, don't do that. Switch them like this, okay? Now, I want you to see a third way to do this problem. Okay? A third way to do this problem. If we, right here, when we had the integral and we had u to the 1/2 du, and I had the negative 1/2 out front, and before I put these boundaries on. Okay? If you really want to leave the 0 and the 1, then you need to write x is equal to 1 and x is equal to 0 down here. You need to do that. Do not just write the 0 and the 1, because it looks like they're u boundaries, and they are not, okay? If you put boundaries here with a du, they have to be u values, unless you communicate otherwise. So let me show you what this would have done. this would have done u to the 3/2 times 2/3, x equals 0, x equals 1, negative 1/3. The problem is we can't plug 1 in for u anymore because that's no longer correct. Now you have to go back to your x's. So this would be 1 minus x squared to the 3/2 evaluated from, now you can say 0 and 1 right there because now they are x values. Okay? So this would be negative 1/3 times, put 1 in for x, you get the 0, right? Put 0 in for x, you get 1, and we get what we knew we would get. We get 1/3 back. Okay? Some students just don't want to change their the boundaries, and that's okay, but it does take a little extra effort on your part. Okay? But we should get the same answer regardless. All right, number 12. Okay, definitely a u-substitution problem, so I'm going to come off to the side. U is x squared plus 4. Du would be 2x dx. I see the x dx there, right? So I'm just going to move the 2 over. And now here's x dx, here's x dx, so I can put 1/2 du in place of that. Okay, so I have the 1/2 I'm going to pull out. Okay, and then I have 1 over the square root of u, which would be u to the negative 1/2. And then I have my du. Okay, boundaries. What's my new upper boundary? If I put the square root of 5 in for x, this would be 5 plus 4, which is 9. So my new u upper boundary is 9. What's my new lower boundary? Well, if I put 0 in for x, I get 4. So that's my new lower boundary. Time for power rule. U to the 1/2 times 2, right? Evaluated from 4 to 9. Now, these are u values. So you don't want to go back to x's if these are u values. If they're x values, then you have to go back to x's. But if they're u values, don't go back to x's. It'll mess you up. Okay? Well, 1/2 times 2 is just 1. And remember, this is just a square root. So square root of 9 minus square root of 4 is just 1. And remember, you guys, with every one of these, how can you check yourselves if you don't want to go and look at my solutions? If you want to check yourselves, you can go and use Math 9, right? 0 to square root 5 x divided by square root x squared plus 4 dx. 1. All right. Next up, just 2 more examples. Next up, u is equal to what? X cubed plus 1, right? Du is equal to 3x squared dx. Okay, the x squared dx, I see. I have to see it. If not, I have to do a different u-sub or do this a different way. But the x dx, I see. The 3 I don't see, so I'm going to take that over. Okay? So in place of the x squared dx, I'm putting 1/3 du. So I'm going to take the 1/3 out, and I think I'm going to take the 4 out as well. So I'm taking that 4/3 out. And then I'll have u to the 1/2 du. Okay? What's my new upper boundary? My new upper boundary would be 2 cubed plus 9. I'm sorry, 2 cubed plus 1, which is 8 plus 1, or 9. My new lower boundary would be 1 plus 1, which is 2. Time for power rule. U to the 3/2 times 2/3, right? Evaluated from 2 to 9, and we already made, these are our u values, so don't go back to x's. These are now u values. Clean up your fraction here, 8/3, and now let's put in 9 for u. We'd have the square root of 9, which is 3. 3 cubed is 27, minus 2 in for u. The square root of 2 is the square root of 2, right? Since that can, and then 2 cubed is 8, but we would have the square root of 2 cubed. Since we're going to get a messy thing anyway, I'm just going to leave it 2 to the 3/2. And that might be the multiple choice answer as well. You might have to mess with that a little bit, but probably that'll just be it. Okay? All right. One more. What to let u be? I'm going to let the u be what's inside that radical, so the cosine x. The derivative is going to be sitting there. So du would equal negative sine x dx. So there's the sine x dx. Here's my sine x dx. So I just need to put negative du in for that, right? So I'm going to take the negative outside. I like to take that negative, or a constant outside. And then I just have u to the 1/2 du. Okay? What's my new upper boundary? What is cosine of pi over 2? Cosine of pi over 2 is 0. What's my new lower boundary? What's cosine of 0? Well, cosine of 0 is 1. Here's the point where, if you want to, we could switch this right quick. If you switch the boundaries, remember you make it the negative of it, so it becomes a positive here. You can do that, but you don't have to do that. We could have just kept that negative and kept the 0 on top. That's fine. All right. Power rule time. So u to the 3/2 times 2/3. And we're evaluating this from 0 to 1. And those are u values. So 2/3 times u, put 1 in for u, put 0 in for u. There you go. And remember, you can go check it. You can always check these. Let's see, integral math 9, 0 to pi over 2, sine x times the square root of cosine x dx. It's thinking. There we go. It's pretty darn close to 2/3, but remember, they use the calculator uses an algorithm, a numerical method, to evaluate that to all integrals. So sometimes you can see a little error in there, right? But it's very close to 2/3. Alrighty, that is u-sub, and we use it a lot. Okay? And remember, you're always getting down to power rule. Alright, fun times.